Good morning, this is your Stat Sensei, Mr. Spensei, and this is 3B.8 exit ticket on fake news. Use the scenario and graph below to illustrate the empirical rule. You must show three standard deviations above and below the mean. You must clearly label the z-scores. Oops, let's go ahead and do those z-scores because all z-scores have a mean equal to 0 and a standard deviation equal to 1. So I'm going to go ahead and put this in there. This is 0, 1, 2, 3, and we go to positive infinity. And this is -1, -2, -3, and this goes to negative infinity. And this in here is my z-scores. We also know that plus or minus 1 standard deviation is 68%. Plus or minus 2 standard deviations is 95%. Plus or minus 3 standard deviations is 99.7%. Okay, well, we haven't done the actual values, but in order to do the actual values, we did the z-scores, but we still need to do the actual values. We need to read the scenario. So the number of minutes per week that politicians and political pundits spend misusing, cherry picking, or widely exaggerating statistics during interviews, press conferences, and social media posts is normally distributed. Okay, we have the normal curve with a mean of 60. So we have a mean of 60 and a standard deviation of 15. And these are my actuals. So these are my actual values. Okay. So let's go ahead and label those. We have a mean of 60. And if our standard deviation, not standard deviation of 15, standard deviation of 10, excuse me. Scratch that out. Standard deviation of 10. So that means all of these are changing by 10. Either a plus 10 or a minus 10. So we know that if this is 60, this means 60 minus 10 is 50, and 60 plus 10 is 70. So between 50 and 70 minutes, 68% of the politicians and political pundits spend between 50 and 70% misusing data. Take away another 10 from 50, and we drop to 40. And this goes to 70 plus 10 is 80. So between 95% was spend between 40 and 80, and that's plus or minus 2 standard deviations. You know what? And just for fun, even though you don't have to use a plus sign, I'll just remind you that those are pluses. And plus, this will be take away 10 again, and this will go down to 30. And this will add 10, and this will go up to 90. And I think they spend a whole lot more time than that cherry picking and using data incorrectly. And we know the red is our actual values. All right. So there's our layout. And by the way, the fact that we had you do this on a warm up and we had to do an exit ticket means it's really important that you know plus or minus 1 is 68, plus or minus 2 is 95, plus or minus 3 is 99.7. And you need to know your z scores, and you need to be able to go mean minus a standard deviation, minus a standard deviation, minus a standard deviation, etc. Okay, so let's go ahead and look at the pretty picture. There it is, everything that I have. But please remember, this goes to positive infinity and this goes to negative infinity. Plus or minus 1 is between 50 and 70. Plus or minus 2, which is 95%, is between 40 and 80. And plus or minus 3 standard deviation is between 30 minutes and 90 minutes, which is 99.7% of the politicians. I guess some spend a lot more time. Please remember, and I'm going to go ahead and write this again, our actual value, actual mean was 60 minutes with a standard deviation of 10. And of course, all z-scores, it doesn't matter. I don't even have to read the problem. All z-scores have a mean of 0 and a standard deviation 1. All of them have that, so we shouldn't mess that up. And this is my z-scores. And this group is the actual. So what percentage spend less than 40 minutes a week misrepresenting data? Well, once again, we already know that this is normal because they told us that. So we're going to go ahead and draw the normal curve. And you need to do the same. We know our mean is 60. And we know our standard deviation is 10. Well, we want less than 44, so we're going to put a 44. And we're going to shade to less, and we're going to shade to theoretical infinity, negative infinity. Now, I know that you can't spend less than 0 minutes, but for the normal, we need to always go to infinity, whether you want to or not. And we want our probability statement to be the probability that x is less than 44 minutes. And we're going to do a second vars norm CDF. Lower bound negative infinity, which is negative 9 raised to the 99th. Upper part of our shading is 44. Mean is 60. Standard deviation was the 10. That was given to us in the problem. And we get 0.0547. Don't forget, this is my lower, and we shaded to negative infinity. We shaded up to our upper of 44. This was our mean. This is our standard deviation. And we truncated in about 5.5%, spend less than 44 minutes. Everyone else lies all the time. Okay? And actually, they use data to do it, so it convinces a lot of stupid people. Please don't be one of those. Listen to what they say, know that they misrepresent, or they're too stupid to understand how to do it. Fake news. What percentage spent more than 83 minutes a week spinning statistical truths? By the way, I used to say, you tell me what answer you need, I'll get you the data to prove it. And you can totally misuse stats, and that a lot of people do that. So in this case, we know we have a normal distribution. They told us that. They told us the mean was 60 minutes and standard deviation is 10. Spend more than 83, so we're at 83 and we're shading up to theoretical positive infinity. So we want the probability statement to be the probability that x is greater than 83. You need to start learning how to do this because it will become a requirement. So second vars, norm CDF. My lower part of my shading was 83. The upper part of my shading was positive infinity, so 9 caret to the 99th. Mean is 60, standard deviation of 10. That didn't change. And we get about 1%. All right, about 1% spend more than 83 minutes. So we have 83 is our lower part of our shading. So here's our lower. Then we shaded up to infinity. They didn't ever stop talking. And then we have a standard deviation, our mean shown of 60, which is our average, and then our standard deviation of 10. Lastly, what percentage of politicians and pundits spend between 55 and 75 minutes each week creatively interpreting statistics? I love that phrase. Oh, I'm not lying. I'm just creatively interpreting them. So once again, we still have a mean of 60, a standard deviation of 10. So 60. Now, we said 55. Well, 55 is definitely less than 60, so I can mark it here. And 75 is definitely above it, so I can mark it here. And our probability statement is the probability that 55 is less than x is less than 75. So once again, gosh, where do you think we're going? You're right, second vars. So second vars, norm, CDF. Lower part of my shading, 55. Upper part of my shading, 75. Mean of 60. standard deviation of 10, and we get 0.6246. So about 62%. Once again, lower part of our shading is 55. Upper part of our shading is 75. Mean is 60. Standard deviation of 10. Really will help if you just start writing LUMO. And our probability statement, lower part 55, upper part 75, and we got 0.6246. Well, I sure hope this exit ticket helped you. Please learn how to draw this. It's going to show up several times. It's going to be really important that you know how to do all this. All right. Good talking with you. Look forward to seeing you on the next one. Thank you.